How you measure the charge of a particle inside of a box? Is it possible? Let's say that a charged particle is inside of a box and you want to know its magnitude. One way to do it is by calculating the electric field it radiates. Since the electric field only interacts with other electric fields, it would be necessary to use a test charge. If you put a test charge outside the box, you can calculate the electric field. When the test charge is moved to a different position out of the box, forces can be calculated and an electric field map can be obtained.
Of the flow of the electric field can be determined by the sign of the charge, so that if the calculated forces are of attraction, then it means that the field has its lines going into the box, while if the forces are of repulsion, it means that the field has its lines outward the box. If the electric field magnitude is big, then it means that there are many field lines passing through the surface of the box. The electric field lines passing through a surface area are called electric flux.
In electromagnetism, electric flux is the measure of the electric field through given a surface. Although an electric field in itself cannot flow, it is a way of describing the electric field strength at any distance from the charge causing the field. An electric charge, such as a single electron in space, has an electric field surrounding it. In pictorial form, this electric field is shown as a dot. The charge radiating lines of flux, these are called Gauss lines. This density of these lines corresponds to the electric field strength, which could be called electric flux density. The number of lines per unit area electric flux is proportional to the total number of electric field lines going through a surface.
Okay, electric flows can be defined as the flow rate of electrons or particles over a system that are inserting inside the area. It can be described as lines over the surface and is related with the Gauss's law because it tells us how particles will act over the surface in charges. So we can say that the charge all over the surface is equal than the one in even one point, in just one point.
Gauss's law is a mathematical synthetication of electric flux under an enclosed surface. That tells us that it is the same in one point and all around surface inside the permittivity. Gauss's law states that the net electric flux through any hypothetical closed surface is equal to the sum of all charges inside the closed surface divided by the permittivity of free space.
Gauss laws can be used to solve complex electrostatic problems involving unique symmetries like cylindrical, spherical, or planar symmetry. Also, there are some cases in which calculation of electric field is quite complex and involves tube integration. Gauss laws can be used to simplify evaluation of electric field in a simple way. We apply Gauss laws in following way. Choose a Gaussian surface, such that evaluation of electric fields become easy. Make use of symmetry to make problems easier. Remember, it is not necessary that Gaussian surface to coincide with real surface, that is, it can be inside or outside the Gaussian surface.